NASA's most distant spacecraft, Voyager 1, continues its journey into the unknown nearly 50 years after its launch. Scientists are puzzled by the strange and confusing data it is sending back that suggests a possible malfunction. The iconic probe was originally launched to explore our solar system, but now it is bringing information from the vastness of space beyond. In 1977, NASA launched Voyager 1 and Voyager 2 within weeks of each other. Voyager 2 was launched first, but Voyager 1 soon overtook it due to differences in orbit and speed, becoming humanity's primary eye in deep space. The two probes, each weighing about 720 kilograms and resembling small cars, used the unique alignment of the planets to travel from one celestial body to the other. By December 1977, Voyager 1 had passed the twins, setting the stage for a series of groundbreaking discoveries. In January 1979, it began taking high-resolution images of Jupiter, recording more than 100 hours of Jupiter's rapid rotation. The 3,750 time-lapse images gave scientists unprecedented views of Jupiter's atmosphere. Voyager 1's cameras captured the rings and the newly discovered moons Thebes and Métis. Voyager 1's journey continued to Saturn, where it discovered 4 new moons: Mimas, Enceladus, Tethys, and Dione. After Saturn, NASA revised Voyager 1's mission, heading beyond the solar system at a speed of 325 million miles per year. Voyager's interstellar exploration officially began in 1990, when it took the famous family portrait of our solar system from 6 billion kilometers away. Voyager 1 has been exploring interstellar space since 2012, surpassing Pioneer 10 as the most distant human-made object. This milestone was not announced until 2013, a year after Voyager 1 entered interstellar space. By November 2018, both Voyagers had left our solar system, and Voyager 1 was now more than 145 billion miles from Earth. Voyager 1 had performed well for 40 years in space, but recent data signals have raised concerns. The probe is now sending signals indicating that its position may be uncertain. Surprisingly, it did not activate a pre-programmed safe mode to alert engineers to the malfunction. The signals reaching Earth indicate that the antenna is working. However, the data is inexplicably inconsistent, giving the impression that the spacecraft is somewhat confused. Engineers have noted that there appears to be a glitch in Voyager 1's Attitude and Articulation Control System, AACS, which keeps the antenna oriented relative to Earth. Despite the AACS issue, the spacecraft continues to transmit commands from Earth and collect scientific data. However, these readings do not match what engineers expected, adding to the mystery of Voyager's status. Among the interesting contents aboard Voyager is a 12-inch gold-plated disc containing messages from Earth, a time capsule containing sounds, images, and greetings from humanity in 55 languages. NASA included these golden records in case an alien civilization collides with the spacecraft. Some speculate that aliens may be trying to decipher the signals. However, this idea has been rejected by scientists who believe the strange behavior is due to a technological anomaly rather than extraterrestrial influence. Voyager 1's AACS system is crucial because it keeps the probe pointed toward Earth. Without it, Voyager's communications would fail, preventing it from transmitting valuable data. Despite recent issues, engineers believe AACS is still functioning, but it continues to be plagued by anomalies. Project manager Suzanne Dodd acknowledged that unexpected problems are natural at this stage in the Voyager 1 mission, given that the probe is already 45 years old and well beyond its expected lifespan. Voyager 1's immense distance presents additional challenges. A message sent from Earth 145 billion miles away takes nearly 21 hours to reach us, and another 21 hours for a response. The 2-day delay makes real-time troubleshooting nearly impossible. Engineers must carefully plan each command, leaving little room for error. The aging of the spacecraft and the harsh conditions of space further complicate matters. Over the past 45 years, cosmic radiation, extreme temperatures, and micrometeorite impacts have likely degraded the system's performance. The Voyager technology, developed in the 1970s, is considered outdated by today's standards, but it still works. This is a tribute to the engineering skills of its creators. In deep space, cosmic rays, Supernovae and other high-energy particles from distant sources pose a constant threat to Voyager's electronics. These rays can cause bit flips in memory, resulting in data errors or incorrect instructions. Engineers designed Voyager with redundant systems to handle such situations, but as the probe ages, the effectiveness of these safety measures diminishes. To address these issues, NASA engineers are exploring several hypotheses. They tested their solutions on Earth, expecting different results for each team. On a space mission near Earth, engineers can quickly solve problems. But Voyager 1's distance requires a more careful and deliberate approach, checking and rechecking commands before sending them. In short, Voyager 1's recent data anomalies may have been caused by the spacecraft interfering with aging electronic systems that have endured decades of intense space conditions. Despite the distance and technical limitations, NASA's engineering team is doing its best to preserve Voyager's legacy. Through careful planning and calculated risks, they hope to extend the spacecraft's mission so it can continue transmitting valuable data beyond the known boundaries of our solar system. Today, the Voyager team faces an unprecedented challenge, troubleshooting a faulty probe more than 22 light hours away. The commands are carefully written, and each response takes a full day to go back and forth, making real-time adjustments impossible. When working on a spacecraft so far from Earth, patience and precision are paramount. You only get one chance to get the command right, so every single command must be carefully tested. We're trying things that have never been done before, and we know that every adjustment can help us regain control. The team suspects that the spacecraft may have interfered with Voyager's attitude and joint control systems, the same systems that keep the probe's antennas on Earth. But testing this theory is never easy. The reality is that in the cold of interstellar space, nothing is guaranteed. Voyager was built to survive the known universe in the 1970s, but it still finds itself in an environment no spacecraft has ever been able to navigate. With every signal that comes back to us, we push the boundaries of human knowledge and technology. Despite the recent setbacks, the Voyager crew sees this as an opportunity to learn and adapt. They continue to send new commands to the spacecraft in an effort to restore clarity to the probe's position data. The Voyager's endurance inspired NASA engineers, some of whom weren't even born when the probes launched. For many of us, Voyager is more than a spaceship. It's a legacy of exploration and curiosity. We may be solving problems, but we're witnessing one of humanity's longest space adventures. Meanwhile, Voyager 1 drifts silently through the galaxy, carrying a tiny golden disk, a message from the universe filled with sounds of Earth, greetings in 55 languages, and music spanning cultures and eras. The Golden Record was created by a team led by Carl Sagan and is intended as humanity's greeting to any extraterrestrial civilizations that might one day encounter the spacecraft. Carl Sagan, excerpt from archive footage, ***, the message from Voyager is one of hope. Hope for humanity, hope for the planet. Despite the cruelty and darkness of the world, we wanted to talk about our longing for the world, our ability to love, and our endless curiosity through this album. As Voyager drifts further away, NASA engineers know that there will come a time when they will no longer be able to communicate with it. But now, all the data they have obtained is being carefully preserved, allowing humanity's most distant explorers to glimpse the unknown. Back at the control center, the team is holding on to one last hope. The next set of commands, transmitted across 145 billion miles, could be the ones that reunite Voyager with its mission. Even in the vastness of interstellar space, they stand firm and ready to listen.